So let's look at writing equations having to do with variation. So this is a really important way of translating between English and algebra, and it will be useful in a lot of different science, physics, engineering, different classes. So let's get started. All right, we have direct variation. And some of the words to let you know that it would be direct variation, y varies directly as x, y is directly proportional, or y is proportional to x. So those would be anything that would be like a linear situation. The cost of, how I make a certain amount of money per hour, so the amount of money I make is directly proportional to the number of hours that I work. Okay, another one is inverse. Y varies inversely, or inversely proportional. And then sometimes there's a combination, a joint variation, where there's a combination of two different things that are affecting your outcome. So let's just look at this translation. So here's what it is in English. P is proportional to the square of Q and inversely proportional to R. So this goes from left to right. So here's P is. So there's where we say that is, there's my equal. Okay, next thing I'm reading along here, and it's just saying it is proportional. So I don't see here the word joint or direct. So that lets me know it's simply proportional. So it's going to be, oh, not yellow. No, because it is just this, okay? It's proportional. So we're looking at this situation. It's proportional. Now, notice that there's a K in all of these. That is the constant of variation. So I'm always going to have a K, and then it's proportional to the square of Q. So I need to take Q and square it. Now it's saying inversely proportional to R. That tells me divide by R. Okay, let's try another one. A is jointly proportional. Okay, I see that jointly proportional. So that tells me that I need to multiply. So I'm going to multiply two things. I have the square root of B and the cube of C. Okay, so I set myself up. A is, so there's my A equals. Okay, anytime there's that word proportional or varies, I know I need to have a K. All right, next up it says the square root of B. Okay, whoops, there's the square root of B. Jointly is a multiplication problem. And then the cube of C, so 3 cubed. Okay, let's try another one. Write an equation and then solve for the constant of proportionality. Okay, y is, there it is, so y is, there's my first part. Now it's saying jointly proportional. Jointly proportional, so I know I need to have my K. And then because of joint, it's going to be a multiplication problem. The two things being multiplied are what comes next, V and W. So V times W. That's what joint proportions mean. Inversely, okay, I see that and I know I'm writing a fraction. Inversely proportional. Okay, write my fraction. What comes next is the denominator, inversely proportional to Z. Okay, so that's the first thing, is you need to write the equation. You're just directly translating from English to algebra. Now, the next thing is we're going to use this information, all of this, to find K. Okay, so step one is write your equation or your model. Okay, and next step is find K. Okay, so now we'll just plug all the information in. Let's see, V is 2, Y is 10. So I'm just plugging these numbers in. Y equals K times V. V is 2 times W. W is 11. All over Z, and Z is 7. And then we just solve this little equation. Multiply both sides by 7, so we'd have 70 is equal to k times 22, and dividing through by 22, we solve for k. Done and done. I am seeing that that could simplify a little bit. Those are still both even, so I'm going to simplify if I can. Let's see, so it'd be 35 over 11. There we go. Okay, so now the applications are where it actually makes sense of why we want to learn this. The distance you are from a storm varies directly. So in my head, I see that. Okay, and I'm picturing when I see that word varies. Okay, I'm thinking in my head, oh, that's right. That's either k times something, k divided by something, or it might be k times something times something. This is the direct, this is the inverse, and this is the joint. Okay, so I want that word to immediately make you think in your head of, oh, that's right, that's one of those three options. Okay, because it's saying varies directly, I'm going to use that top one. Okay, so the distance you're traveling from a storm varies, so I'm going to let d equal distance directly as the time interval. So I need to have something for t. Let t equal my time interval between seeing lightning and hearing thunder. Between seeing lightning, there's my lightning, and hearing thunder. Okay, so now I'm going to write that as an equation. D equals k times t. Right? That's what it means. Varies directly. So what comes first in the sentence from left to right? D. There it is. There's my D. It varies directly. That means I have an equal sign and a k. That's what it means to say varies directly. Now what comes next from left to right is the thing that's going to come at the end of the equation. There's the t, the time interval. Okay, so step one I did. I wrote my equation. I defined my variables. I wrote my equation. Okay, we're ready for the next step. Okay, suppose, now we're giving ourselves an example. Suppose it takes a certain amount of time and we're a certain distance away. Now we're going to actually solve the problem. The problem doesn't come until at the very end. If the time interval between the lightning and the thunder is now 8 seconds, how far away is the storm? It's often really helpful to find the equal or the question mark. This is what we're supposed to be finding. How far away is the storm? I even sometimes just write it. The storm is a certain, let's see, it's in feet. Okay, that just helps me clarify what is it I'm trying to do here. Okay, so once I wrote my model, now use the example to find k. Then we're going to answer the question. Okay, so first we're going to try and find k. Here's the example. 4 seconds, and we have a certain distance away. Okay, so plug those numbers in. Distance is 4,320. That's k times time, 4 seconds. Dividing both sides by 4, we get that k is equal to 1,080. Am I done? No, it's tempting to want it to be done, but I'm not. Now I have to actually solve the problem. Okay, so all this work and I haven't even solved the problem yet, but that's okay, right? Now, okay, now we need to know the distance. K is 1,080 and our time is 8 seconds. So just multiplying those out, and we get that the storm is 8,640 feet away. 8,640 feet away, so not quite 2 miles. And I wrote my answer in a complete sentence, including units with a period at the end. Now I'm done. Okay, let's try another one. The size that a potato grows. This is good for, because I have teenage kids who like potatoes, eat a lot of them. Okay, the size that a potato will grow is directly proportional. Aha. In my head, I'm thinking, oh, that's a k times or k divided. That's one of those proportional ones. It is directly. So I'm going to have the size is equal to k times the amount of nutrients. So now I need to define some variables here. Let S equal size of my potato. Okay, and the amount of nutrients it receives, let's let N equal nutrients. And now we also have this inversely proportional to the amount of surrounding potatoes. Okay, so let's let A equal amount of surrounding potatoes. Okay, define variables, done, right? Our equation, I'm getting there. So directly proportional. What comes first is on the left side. So the size is, there's S equals directly proportional. That means K times the amount of nutrients. So K times N. And now it needs to be inversely, so divided by the amount of surrounding potatoes, divided by A. Okay, so defined my variables, wrote my model. Okay, what comes next? Use example to find K. Okay, to get myself organized, I'm going to go to that equation or equal or question mark. What am I trying to find? Here we go. How big will the potato grow if it gets a certain amount of nutrients and has 8 other neighbors pulling nutrients out from the soil around it? Okay, so I know I'm going to want to know the potato. Grow to a certain size. Okay, and I'm looking for, and I can actually just put that in regular, it will grow to a certain number of pounds. I'm looking at my units there. Okay, now I need my example. Okay, here we go. A potato that received 10 ounces of nutrients. So in the example, I have nutrients is 10, 12 potato neighbors, so A equals 12, and it grew to a certain size. That's my S. S equals 0.5. Okay, so we're going to plug those in. 0.5 equals K times N times 10 divided by 0.5. Oh, wait, divided by A. That should be a 12. Good. All right, so I'm going to just multiply both sides by 12. Half of 12 is 6. Dividing by 10, we get 6/10 is equal to K, and that would simplify to 3/5. So I know what my K is, and now I actually solve my problem. Okay, so now, how big will a potato grow if it has 5 ounces of nutrients? So N equals 5, and it has 8 neighbors. A equals 8, and I want to know what my size is. So S equals K. I just found that K is 3/5 times N. And okay, so times 5, and that's all over A, which is 8. And then I'll just simplify this a little bit. The numerator there can simplify. That's just a 3. So S is equal to 3/8. So the potato will grow to be 3/8 of a pound. And that is done.